Alright guys, so moving on to our next problem. And now they're asking us to subtract rational expressions. So they give us two rational expressions and they want us to subtract. Okay, so this is very similar to adding, except the only difference here is we're going to subtract. Now, we know that when we add rational expressions, we need to get the same common denominator. Well, it's the same thing with subtraction. We need to get the same common denominator between these two rational expressions before we go ahead and perform the operation, which in this case is going to be subtraction. Okay, so looking at our denominator here, we have x plus 2, and then we have this x squared minus 4. Okay, so what you're going to want to do here is you're going to want to expand this, you're going to want to factor it. This x squared minus 4 is a difference, right, of two squares. So we can go ahead and expand this. So I'm going to rewrite this problem with the denominator expanded. So we'll have 2x squared minus 16, and then we'll have x plus 2 and x minus 2, right? This is going to be a difference of two squares, so we just factored it. Then we'll have minus x plus 4. This will be all over x plus 2. Okay, so we need to get the same common denominator here. So if I look to the left and I look at this rational expression here, okay, my common denominator is going to be x plus 2 times x minus 2. Well, here I have the x plus 2, but I'm missing the x minus 2. So what I'm going to have to do here, I'm going to have to multiply both the bottom and the top of this rational expression by x minus 2. And again, we multiply both the bottom and the top. That way it stays equivalent, right? We're not going to change it. It will keep its equivalency by multiplying both the bottom and the top. All right, so just remember that step. You're not just multiplying the bottom, you're also multiplying the top. And again, we do that to keep its equivalency. All right, so let's go ahead and do that. We're going to multiply by x minus 2 on both the bottom and the top. Okay, and let's figure out what we get here. So we'll rewrite this in another color. So we'll have 2x squared minus 16 all over x plus 2, x minus 2, okay? And then we have minus, and let's go ahead and just do this operation out right now, right? Two binomials, we're going to use FOIL here, so we'll do x times x, which is going to be x squared, so we have x squared. Right, so that's first. Outside is going to be minus 2x. Inside will be positive 4x, so a minus 2x and a positive 4x makes plus 2x. And then last is 4 times a negative 2, which is going to be negative 8. And again, on the bottom, we'll have our x plus 2 and x minus 2. Okay, so our denominator is now both the same on both of these rational expressions. We can now perform the operation, which is going to be subtraction here. Okay, so just be careful when you do subtraction here, because this negative sign is going to be distributed to each term on the top here. So this negative will go to the x squared, to the 2x, and to the negative 8. Okay, so just be careful with that. So when we look at the first one, let's go ahead and erase this. I'll write it on the top. So we'll have a 2x squared minus an x squared, which is just going to be x squared. So we get x squared. Alright. So continuing on, well, I don't have just an x term here. I only have one here, so it will just be minus 2x. So minus 2x. Okay. And then our constant right here, the minus 16 minus a negative 8. Right. So two negatives will make a positive here, so this becomes positive 8, so it's really negative 6 and a positive 8, which is going to be negative 8. Okay, and this is all over x plus 2, x minus 2. Okay? Now, at this point, you may say you're done, but just be careful because we have a quadratic on the top, and there's a possibility that we can factor this and then cancel out a common factor on both the top and bottom. So you want to simplify this down as far as you can. So we're going to want to factor the top here. And again, you can use the AC method if you wish to do this, or if you can visualize this, that's fine as well. You can put it right in the factored form. I'm going to put it right in the factored form, but if you need to use the AC method, feel free to do so. Okay, so when we put this in factored form here, we're going to have the following. Okay, so we'll have x minus 4, and we'll have x plus 2. Okay, and then on the bottom, we have x plus 2 and x minus 2. Okay, well looking here, I have a common factor on both the top and bottom of x plus 2 and x plus 2. So I can cancel that out. So this will cancel, and this will cancel. And my final answer here, let's do this in blue, will be x minus 4 all over x minus 2. And again, you could write this without the parentheses if you wish. I just added them. So on the top we have x minus 4 and x minus 2. That is going to be our final answer. Okay, so that's simplified down. We just perform the operation and that's that. Now if they ask you, state any values for x that make this undefined. So if they ask you that, state any values for x that make this rational expression undefined, you're going to go back to the point where, okay, you had this fully expanded out right before we simplified it down. So at this point right here, so if you canceled out any common factor, you want to go back to that point, okay, if they're asking you to define any values for x that make this undefined. And we know that when we divide by 0, okay, that will make a rational expression undefined. Okay, so when we divide by 0, anything divided by 0 will be undefined. So going back to this point right here, not here, but right here, okay, what would I have to plug in for x in order to make this bottom part 0? Well, if I make this negative 2, this will be negative 2 plus 2, which is 0. 0 times this will be 0. Then I have division by 0. So that tells me that x cannot equal negative 2. Okay, now let's look at this one, this factor on the bottom. What would I have to plug into x? Well, 2, right? 2 minus 2 is 0. Again, 0 times this would be 0, and we have division by 0. So x can also not equal 2, because at these values right here, it will be undefined. Okay, so this right here would be your final answer. Here it is simplified down, and here are the values for x that would make it undefined. Okay, and that is subtracting rational expressions.